All right, everybody, welcome to our second SpatialAnalyzer technical webinar. We are working on point cloud capabilities. This time, so just to introduce myself initially, I am Anna Smith. I am an application engineer based out of Jacksonville, Florida. I've been with New River Kinematics for about a year now. So I just want to get started by first going through our website a little bit for you guys so you can see all the support options we do offer. So if you come to our main website, kinematics.com, scroll down to NRK News and Events. There's three big links here that you'll want to pay attention to. We have our latest software release link that can take you to download the latest release we have. Right now, the latest official release is 11/21/2019. I will be doing our webinar in a beta today, in our latest beta. So next up we have our SA community page. This can be a very helpful resource for you as you're getting going with SA or have some specific questions. And then our live webinars link. So you'll have access to our upcoming live webinars so you can see the dates and topics that those will be on. And as well as the previous webinars, those are all recorded and can be available via that link and also on our YouTube channel, which is another great resource as you're getting going with SpatialAnalyzer. So real quick, just to point out our community page, it's a great resource. You can see different categories here if you have some specific questions on CAD, measurement, cloud-based inspection, which is what we're going to be talking about today. Any specific GBMT questions, you can find some answers to those in there. You'll find various articles within each category. So that's really it on just the introduction to see our website and introduce you to myself. From here, let's go ahead and go to digging into SpatialAnalyzer. So I'm just going to open up a new file so we can get going. All right, so when you open up SpatialAnalyzer, if you're in a version 5.16, 2019 or later, you'll have our option of using these ribbon bars. This is our new user interface. It makes commands very easy to find. It takes commands that were once 5, 6 menus deep up to the surface, so you can access them with just 1 or 2 clicks. You can see what version you're in down here at the bottom. Right now you can see I'm in our beta, or 3.5.2020 beta. So we'll be working in that today. Almost everything that we touch on today is available in that latest release though. So as we get going, you will start by importing some cloud data. Most of you probably know that you can scan directly into SpatialAnalyzer, but if you scan into another software, you can import that data into SA, and that's what we'll be doing today as I'm not connected to a live instrument. So to do so, you can do that in 2 ways. You can drag and drop, or you can go up to our little hamburger button up here, go to Import. We're going to go to our cloud data file formats. We accept E57 as well as PTX. So I know I have a PTX file. I'm going to go ahead and bring in my demo part scan and hit Open. All of our defaults here will work for this file. So I'm just going to go ahead and hit OK. It's going to work on importing that data. Get a little pop-up. My file has been successfully read. Fantastic news. All right, so now we can see we have our scan of our part. Some of you might recognize this part. It's our SpatialAnalyzer demo part. So it's just a base and a vertical where we have a bolt hole pattern, a slot, our main bore here. But when we did take this scan, it was sitting on a table. So that's why you can see this overspray here. That's our scan data on the table. And this is a common problem that you might run into when you are scanning parts. You'll get some overspray. There's a really easy fix to that. We're just going to use a clipping plane to take that out of our file here, clean it up a bit. But first I am going to adjust my visibility of my cloud real quick. And to do that, I can use my hotkeys, Control-T. That'll bring up this cloud display dialog box. I can also get to that same option by going to my Clouds and Surfaces tab. Directly below it is this button, our display control, and that will also remind you if you hover over it of the hotkeys. Control-T for that. So I'm just going to bump my size up from 1 to 2. Hit apply, and that just bumps up each of the cloud points twice the size. Just a nice visibility there. So if we go back and we want to clean up our data, let's go ahead and we're going to extract a plane so we can use it as a clipping plane. To do that, I'm going to go, again, staying in my Clouds and Surfaces tab. If I go to my Build from Cloud subcategory and hit Geometry, we're going to work on extracting our geometry from our cloud. So I'm just going to want to make a plane here from some of these points. So to do that, I'm just going to select my plane button, and it's going to prompt me, select Geometry Extraction Seed Point, and that's just going to be the initial point in which SA is looking to extract this geometry. So if I come in, click one of these points, there we go. We have a nice plane. It's very representative of the table that the part was sitting on. So from here, I'm just going to go ahead and select OK. We'll walk through some of the extractions of these other geometries in a little bit, but right now I'm just going to clean up my data and do the plane. So now that we have our plane that we want to use as a clipping plane, we have to assign it as the cloud's clipping plane. And to do this, we're going to go into the properties of the cloud itself. So if I hit my drop down on my scan stripe cloud, I can get to the properties by either double clicking on the cloud listed or right click and select properties. From here, you can come down here and you see this nice clipping plane section. We'll be sticking in here. Going to configure clipping planes. That'll pop up this dialog box. And we can go ahead and select add, since we'll be adding a clipping plane here. SA will then prompt me to define my object that I'm using for my plane. I'm going to go ahead and select my plane. So I say clipping plane, but it really gives us this opportunity to clip by volume. And right now, it's using this top side of this cube to clip, which that's not what I want to clip. I want to clip in the opposite direction. So I'm going to drag if you can rotate around, I can see that if I hover around, I can use these to control my clipping volume. Drag a little bit higher, make sure I'm not clipping any of my actual part. And I'm going to come down and select the bottom face of my cube that I want to use as my clipping plane. I'm going to drag that up till I just start clipping that table data. So you can see, you can just drag it. There we go. Now I've clipped my overspray there. You can see both of these are highlighted, so you can use more than one side of this cube as a clipping plane, and you can toggle them on and off by just hovering over it till you see it completely highlighted and click it. So right now that's deselected. If I did want to clip in another direction, I can hover, click that, it then clips that cloud halfway down the center of it. We don't want that right now, so I'm just going to toggle that back off by clicking it again, and we're good. I'm just going to keep that one plane as my clipping plane. So I can go ahead and close that from here. And there I can go ahead and delete my hidden points. It will ask me if I am sure. Are you sure you want to remove these hidden cloud points? Yes, I am. We're not going to be using those overspray points for a fit for any reason, so I hit yes. So now I have my reduced cloud. I'm going to hit close. From here, you might notice these points down here. Those are actually the points that were extracted from the cloud to define that plane, and they are now in this category, point clouds. I'm just going to hide those for now by selecting show. I'm also going to hide that plane. We only have visibility of our measured cloud. Let's come in now and look at some of this additional geometry if we'd like to extract that. So if we go again and go for geometry, we have all of these options. We already worked with our extracting of a plane. If we hover over the circle option, if we left click, it extracts a single circle from a plane. Right clicking will extract multiple circles, and alt left clicking will extract a circle from a cylinder. Let's try this right click multiple circles from a plane option. And we can look at this top plane here and we can see we have multiple circles on it. If I right click, it'll be prompting me to select my seed point. select anywhere on this plane. And you can see that SA has extracted all of those circles on that plane automatically. So now in our tree, we have a circles category and we have a point cloud for each of those circles, and those are the points it used to form that circle. So from here I can just go ahead and close out of that. You can also do that same process to get slots and cylinders. So a very handy tool there. I'm just going to go ahead and hide these. We don't need to worry about those right now. So right now we've worked with our cloud solely, but let's say we want to bring in some CAD and align it to our CAD so that we can compare it and see if we have any deviations from our design. So to do that, it's very easy. I'm going to go ahead and bring in my CAD. And instead of going through my hamburger button, I'm just going to do the drag and drop method this time. I'm going to drag my SA demo part into my graphics view and import. You'll then come up with a list of everything within that file. Here, I know I'm not going to worry about the constructed points and lines, so I'm going to deselect all of those by selecting that main checkbox. But I do want to bring in my base and vertical. Those are my two surfaces. And we will be doing some GBMT fun in a little bit, so I'm going to come down here and bring in my annotations. There we go. So that's grabbing all of my annotations. I'm not bringing in my lines and points. I am bringing in my surfaces. All right, so it comes in. This is a sample file, so it already is pre-aligned. I'll move it so we can walk through the alignment process. You can see it came in with all of the annotations. I'm going to go ahead and hide those since we won't be using those right now. And let's go ahead and move the cloud so we can walk through a very fast cloud to CAD alignment. I'm just going to move it by right-clicking on it, selecting move, and going through let's move it a little bit in X, move it a little bit in Y, and close that. So we are no longer aligned to our CAD. To quickly align to our CAD, you just right-click on the cloud in the graphics window and hit Align to CAD. It's going to prompt me to select my surfaces that I'd like to align to. Do that quickly just by selecting each surface in the graphics view and hitting Enter. It will perform a mesh and work on that alignment, and there we go. We are aligned. And select Yes, and there's our alignment. So sometimes we will have parts that are very symmetrical, or your cloud and your CAD might come in flipped upside down, so it could get stuck in the local minima on a fit. And that's a situation in which just working through the cloud to CAD might not yield the best results initially, and you'll want to do a rough alignment first. So let's walk through that, because that is that I've worked with quite a few symmetrical parts in which you want to have some hands-on time at first to get it roughly aligned, and then run your detailed cloud to CAD alignment. So to do that again, I'm just going to move my cloud back. Let's move it again, a little bit in X, a little bit in Y. Let's add some rotation just for fun. All right, and close. To do a rough alignment initially, we're going to go to Align, this cloud to CAD option. So this is, if you just click this button, it's exactly the same command as right-clicking on the cloud in the graphics window and selecting Align to CAD. But if we do this drop-down, we have this option to do Align Endpoint Cloud to CAD. And this is essentially going to walk through the same process as if you had done a quick align live. So if we hit that drop-down, Align Endpoint Cloud to CAD, I'm prompted to select Moving Cloud for alignment. The cloud I'm moving, this guy. It'll then pop up this additional window that just shows your cloud that you're moving. And you can move that around independently of this window. If you do have multiple monitors, this is a nice one that you can just drag over to your other monitor to open up some screen real estate. But I do not right now, so I have my cloud visible here. Then I'll make my CAD visible in this window, so that I can match them up nicely. So from this point, I'm going to go ahead and select my control points option, it says that I need at least 3. This is just a rough alignment, so you can do a minimum of 3, but you can do as many as you'd like. I'm just going to go ahead and do one on this surface here, throw one down here, and then add one on the side. Again, it's a minimum of 3, but you can add as many as you'd like just to get that rough alignment. From there, I'm just going to hit enter since I'm done selecting those control points. We can see that their point count is 4 here now. They have their own point group. I'm now going to hit rough align points, and it'll walk me through the process of selecting those points on my cloud that match up with that CAD. So the CAD point, the control point, is now highlighted in red. I'd like to match that with the cloud point. I'm going to go ahead and select about here. Once I select that one, it auto toggles onto the next one. So on this side, so I believe that's down here in the center. Grab one of those. And then this guy on the side. Then enter when done. So I select enter. I can select perform alignment. It'll perform that rough alignment, essentially doing a best fit of those points. We have a resultant RMS of 0.0167. So we have a nice rough alignment here. Now if we select exit, that's going to accept that alignment. And there we go. So now we are roughly aligned to our part. And this is when I would then again do the full cloud to CAD alignment to get an overall best fit. So I select my cloud and my 2 surfaces, enter when done. It's going to mesh it and perform that alignment here. So before I hit yes, and that's perfectly acceptable if you're okay with that alignment. If you're not 100% happy with it, you can select no. A window will pop up, say retry with finer alignment mesh. And select retry. It'll then create a finer mesh and retry that the cloud to CAD alignment. If we want to apply that alignment, we select yes. Here we go. We have the best alignment thus far. So now that we are aligned to our part, we can go ahead and create a relationship to check some deviations between our cloud and our CAD model. To do that, if we just go to our Features tab, we have this Relationships category at the end of this Cloud category. Do Clouds to Objects. So if we select our point cloud, enter, select our objects, we have a vertical piece and a base piece. It now has constructed a relationship. These other relationships you're seeing in here are the geometry that we extracted from our cloud a little bit earlier. So right now we're looking at this cloud to object relationship. We do have a max of 0.172. I know this part is good, so that's just going to be a little bit of noise in the data. Depending on the hardware you're using, if you're using an older scanner, it's going to have a little bit more noise. That's the situation that we're in at the moment. So I can go ahead and remove outliers. I can do that by going into the properties of that relationship, and I can get there by either double-clicking on that relationship or right-clicking and hitting properties. And here we do have an outlier rejection option. You can set high and low limits individually or set symmetric. So if I come in here and let's say, I know this part's pretty good, so let's set it to 30 thou and hit OK. All right, so we've worked on rejecting our outliers. If we hit OK, we now have an ABS max of 21 thou with an RMS of 3. In those properties, also just some other settings, some sampling options. And now we're using fitting at endpoints. We can up that to from 200, 20,000 if we'd like. We can also view voxel cloud display. So from here, we view our voxels, and what a voxel is a volumetric volume area that will contain cloud points. If we go to our voxel cloud settings, our voxel size you can set itself, and that'll tell you, that's going to set the volume of that voxel, and then any cloud points that fall within it, it's going to look and look at the average of all of those and then use the cloud point that's closest to that average to represent that voxel and give the deviation there. So we use raw data. We won't be doing any averaging. These are going to be real points that we're using. We're just using the voxels to trim it down visually. You can also adjust the amount of minimum point count per voxel. So if you're wanting to have some more voxels, you can up that. We can decrease the voxel size if we'd like more. Take it from 0.1 to 50 thou. Auto detect if you'd like. Voxel rendering diameter, you can adjust that as percentage of the voxel size. If it right now is 125%, we can drop that down to 75% if we like, and adjust the border and say 5% of that voxel size. And from here, you can use voxels for surface analysis. And right now, since we got to this through the relationship, it's going to be using this relationship, the deviations to the CAD for colorization. If we go to colorization, you have discrete colors as well as continuous, using max deviations and min deviations. If we go back, we can show our color bar. So we have numerical values that align to those voxels. Got our color bar visible now. So this might be a point in time where you'd like to take a screen capture, maybe include in a report later on. We won't be talking about reporting too much here. That will be covered later on in another live webinar. But to take a quick screen capture, we'll look at that. You just come to the reporting tab and select this little camera button. It's going to take a screen capture of this graphics view. You now have a pictures category in your tree, and then you can drag and drop that photo into your report or click on it and view it in your report bar. So from here, we've gone through voxels, looking at those deviations. Let's go ahead and, right now we're viewing our cloud as voxels, so to view it back as raw data, if we go to our cloud properties, we can go to our standard cloud display and close. And let's say now we want to look at and compare our cloud data to our nominal geometry. It's another thing that's very easy to do. We can go to Features, select our nominal from CAD. Let's go ahead and take this main bore. I'm going to call it main bore. From our CAD, we're going to go to Extract Nominal from CAD, and using for data association, we'll hit this drop down and use Proximity Filtered Clouds. So it's going to use any clouds in a certain proximity to those CAD faces and assign them to that relationship. So from there, I'll go ahead and just hit cylinder. It's going to prompt me to select my cylindrical face. Come in here and select that face, and then select clouds. So now we do have a cloud and our constructed cylinder. If you select on that relationship, you can then see the deviations from our nominal.
Switch scene.
So we have our network
Switch
copy.
scene.
Hopefully you guys can see what I'm doing in SpatialAnalyzer right now. Constructing the cylinder and comparing to nominal. We'll keep moving along. So from here we've got our measured cloud and our nominal. We've created a comparison. If you'd like to see some it looks like we might have lost visibility on this. So let's try something with you guys. Hoping you guys can see SpatialAnalyzer. Okay, so it looks like we're back. Sorry about that. A little technical glitch with our streaming. So I've constructed, I've used auto proximity to gather that data and assign it to my nominal. We've now compared that cloud data using the auto proximity to our nominal cylinder there. We can see our geometry relationship by clicking on that in the report bar. That'll give us the nominal diameter from CAD at 1.5748 and our measured at 1.5822. We can see our delta. If we want to get a nice visual using vectors, we can do that as well. All right, so we're going to touch on these vectors again, and then go back to the voxelizations, because it sounds like that we lost visibility and screen sharing at that point. I'm going to go ahead and go to vectors at this point. So to do that, I'm going to go to this relationship by double-clicking and just say fit geometry points in my vectors option. So you can have a nice visual on the fit of those points to that nominal. All right, so from here, let's jump back and touch on the voxelization one more time. I'm going to go ahead and hide those vector groups now. Bring back my full scan. And once again, construct a voxelization. So I can do that by clicking on that relationship, voxel cloud display. So right now the colorization was already set, and I did that by going to the voxel cloud settings. You can adjust the size of your voxels there, or auto detect that size, and adjusting the rendering diameter as well as the border. This is just for the display settings of your voxels. It's to a relationship right now, so the colorization is representing that deviation. And in that colorization, you can adjust that. Right now our high limit is our max deviation, low is min. If you'd like to adjust that to a custom value, that's available. We also have different color profiles. It's on continuous at this moment, but we do offer tolerance, go, no go. Right now our high tolerance and low are beyond our deviations. So good for us, but that means just all of our data is gray, so it's in that good to go zone. Just gonna go back to continuous at this point, give us that nice visual, and okay. We're good there. To show my color bar, just a checkbox in this bottom left. Okay, and okay, so that's how we get our voxelized cloud. And then to get that screen capture that you probably heard me talk about but didn't see it on my screen, again, I apologize for that. I went to the reporting tab and just hit this capture button. So if I select that, it'll send it down to this pictures section in my tree. If I select photo, that photo, it'll show it in my report bar. Then you can then drag and drop that photo into your report that you construct later on. So that covers our cloud to CAD alignment, as well as the voxelization to show the deviations. So let's touch on GBMT real quick so we can combine kind of what we did this week and what we did last month in our GBMT live webinar. So I'm going to send this back to a scan stripe cloud in my properties. Hit standard cloud display. Apply, close. I'm going to go ahead and hide this cylinder cloud by right-clicking and hiding all my clouds. I'm going to go ahead and hide that cylinder as well. So we have our cloud and our CAD one more time. So if we're going to start working through our GBMT process, if we right-click on our annotations category and select show all, we now have our GBMT. visible again. So we have our cloud, it's aligned to our CAD, and we have our annotations, which are assigned to the surfaces on our CAD. We just need to create that link between our data and the annotations and evaluate. To evaluate them, we're going to have to create feature checks. So to do that, go into the GBMT tab. This is our feature checks category. So we're going to make from all CAD annotations. So we now have this feature checks category within our tree. And that's listing everything that we need to now assign data to. Since we are aligned to our CAD, we can use our auto filter tool. That's right here. So if you hit that drop down, you can filter to just selected checks. And this is again going to use proximity, similar to how we did the cylinder fit to the CAD faces. So we can use filter selected checks if you just want to do a couple checks at a time. Here we are going to filter to all checks. It's prompting me to select individual points. We don't have any probe data here, but if you did have a combination of scan data and probe data, you could use that. So I'm just going to hit enter since I don't have any. I don't have any point groups since I don't have any probed data. I do have a cloud, so now is when I'm going to select my cloud. This allows you to adjust the offsets in which it's looking. For the proximity, I'm going to go ahead and select OK. So run the filter checks. This is now using proximity to assign data points to each of those annotations. You can see it populating each of those now. We've got a check mark saying, yes, we do have data. We can run those evaluations. And that's also subdividing each of that cloud into clouds for each of those spaces. So if I go in and hide my main scan stripe cloud now, I'm going to hit right click and show. You can now see all the individual clouds that have been fit and assigned to each of those spaces and annotations. So from here we've got our data, we've got it assigned to our annotations, now we just need to evaluate. And that's as easy as selecting this just evaluate all button. That's now going to evaluate all of our GBMT checks and give us pass-fail results. So from start to finish, if you have a scanner, CAD, and you're running GBMT checks, it can be as easy as taking your data, doing a cloud to CAD alignment, running auto filter, and hitting evaluate all. And you can run all of your GBMT checks with just a few clicks. Very easy. And if you do have some additional questions on using GBMT with an SA, I would urge you to check out our last webinar recording that is available again on our YouTube channel or via our website link. So that's it for this file. I do want to jump into another file real quick to show something that is new in our beta, but it is a great resource. So if we switch over to this file, we can see we have some scan data taken from a tracker. We do accept now intensities and RGB information. This file only is using intensities, but we can filter on the intensities of the data. So just to walk through that process real quick, I'm just going to right click on this scan stripe cloud in my tree and go to RGB filtering. So you can now filter on quality and intensity as well as the RGB. We just have the intensity values here. So if I select that intensity radio button, I can adjust these if I only want to look at the data I got the most returns on. So if I move those in and then I hit apply filter, you can see it's now removed some of the data that was outside of that zone. And you can continue to adjust this as much as you'd like. So that's filtering on intensity. You can reset to all cloud points, make them all visible. If we switch to quality, our red's going to be over here at the back end, and then our blues up here. So if I come back here and apply, it's removing all of that red data, or that lower quality data. That just has a high broadening value. That's all the red means. So if we want to get rid of the red, we can go all the way to that side. If we take it all the way in the other direction, oh, sorry, got to bring back all my cloud points to make them visible again. And now go this way. It keeps all of our red. So we do have options on visibly filtering there with this nice graphics histogram now. And then just reset all cloud points visible by hitting that button, and it'll bring them all back. All right, so that is it for our cloud point capabilities within SA on this live webinar. Let us know if you have any questions. We have our support line, and you can also contact me at anna@kinematics.com. If you'd like to rewatch this, or anyone you know missed it and they'd enjoy it, we'll have a recording and a link up on our YouTube channel once again. Hope you all enjoyed it. Our next one should be the first Friday of April, which I believe is the 3rd. So come back in and tune back in for that. All right. Thank you, everyone.